So the run just finished, and this this window came up, and you can see the chromatogram came out in the runtime window. Now if we look at the report, that has actually an even clearer view of it all. And you can see that, here's diode array signal 1, 254 nanometers, and the chromatogram generated from the 254 nanometer peak is here. It has major peaks at 1.36 and 3.37 minutes, right? And then if we scroll down here a bit, we see there's a second chromatogram that was recorded at 255 nanometers. And there's really no point in collecting two chromatograms at such insignificantly different wavelengths, but you can generate greater sensitivity in one chromatogram than the other to a particular analyte by choosing the wavelengths. So you could generate a whole bunch of different chromatograms because you have a whole bunch of different collection wavelengths that you could look at. Okay, so now, sneak around the other side here. If I scroll down here just a bit, we can see that each of these numbers corresponds to what the software believes was a eluted compound or a peak in the chromatogram. And the table that follows has retention time and area in this unit of milliabsorbance seconds. And it's the area that you want to use for quantitation. Right? The retention time is identification and the area is quantitation. So it can be a lot of information, it can be confusing, but remember it's just time and area. And when you make a calibration curve from these, you use area and concentration. So there's a little tidbit for you. Now, this should have printed out, or we can print this out by clicking the print button here, and it should print out over on the printer over here, down on the end of the bench. So that's pretty much it on a single run, and I'll briefly walk through the setup of a sequence. Okay. So first of all, I modified this method. So I'm going to do method. Oops. First, it says run in progress. Oh, I see. It's going to run to 10 minutes to clear out the column. That's probably more than is necessary. But I'm going to go ahead and click stop to stop this acquisition run. See if that works. Then I'm going to go to method, save method as, and I'm going to give it my name so that Jamie's method isn't overwritten. So when she goes to get her method back, she won't get my method. Alright, so now let's go to the sequence. And I'm going to go to start at sequence parameters, operator name, data file naming. Data file naming, I recommend prefix and counter mode. So in prefix and counter mode, I'll check that prefix and counter radio, and I know you guys can't see, I'm sorry, but you can sort of crowd around a little bit. Prefix and counter mode, you set the prefix as something recognizable to you, something you write in your notebook, and then every file in your sequence will have that name, and then it will have a counter just which is the order in which it was injected, 0, 1, 2, 3, 4, 5. Not to be confused with the position in the auto sampler, it doesn't record that in here, but it's just a serial number. Okay? So sequencing, prefix and counter, you can specify a subdirectory. So I just gave a name, Roger, for my subdirectory. That works too. Where all my files go in one place. If you want to, in your notebook, you can print out the path. I'm going to put in a post-sequence. Oops. I'm going to put in a post-sequence command macro. I'll pull it down off the list, which is shutdown. Okay. and then I'm going to just say OK. Then I'm going to go up to Sequence, Save Sequence As, and I'm going to call it Roger. Okay. Now those are the sequence parameters. Now in the sequence table, I get to specify where in the auto sampler everything is. Okay. The vial is the number of the location in the auto sampler. So that can be 0. The sample name is simply something that I specify, recognizable to me. The method name comes off of a pull down, and I know mine is roger.m, right? So it should also be in the list here. There I am. Injections per vial 1. This is a sample, not a standard, right? Now I'm going to append a line here. And now let's say if vial 1, I had a standard, right? I want to run the same method, do 1 injection, and now instead of sample I'm just going to call this guy a calibration standard. Right? And then I'll fill out this sequence with the remaining calibration standards. Oops. Okay. So that's one way to go through this. Now, on each line, there's a unique sample information field. And the sample information field is important because it gets printed out. And when you get a big pile of printouts, sometimes it's hard to know what's what. So I encourage you to use that sample information field to identify what's in your sample and to be aware that it's unique for each line in the sequence. So I'll give you an example. I'm going to click on line 1 and it says sample info for vial 0. I'm going to say 1 to 5 dilution of pure Diet Coke prepared by Roger on 2012 to 21. Okay. Standard 1 might be 10 ppm caffeine and 30 ppm benzoic acid in water. Something like that. That could help. You could also specify C18 column, method, roger.m, 60, 30, 10, water, methanol, acetonitrite. And then so on and so forth for the remaining standards. Then you OK that and do sequence, save sequence as, roger.s works, be OK. I'm going to replace it. And then when I'm ready to, now when I push the auto sampler button here, we see the 3 calibration standards in the sample, and the instrument is now expecting this cassette to have sample, standard, 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 right? And so when I get ready to do a full run, I'll load up the auto sampler thusly. And so long as things are in the places where they're expected, I can then use this button and click start, and it will start a series of runs with that method, etc. Now, one thing I would like to change before we're done is in the method that the post time was too long. So I'm going to edit the method, and the post time I'm going to give it like 2 minutes. A long post time is needed when you change, when you do solvent gradients, because one of the Achilles heels of solvent gradient processes is that the column actually has some kind of slow equilibration with the mobile phase. So if you run from, say, 30% organic to 80% organic over the run, then you start the next run and you want to start at 30% organic again, you need to just run 30% organic for, say, 5 or 10 minutes in order to re-equilibrate the column with the new solvent composition. So that's a little caveat. In this case, we're running isocratic, so I can have a short post time without any complications. Okay? So this is the time between method runs, and there's the time of the method run. So I'll OK that, and then I'm just going to OK all those dialogues. And then we'll do method, save method, and OK. So now my method's saved. I'm ready to set up a calibrated run, and everything should just print out as it goes. You can set it and forget it because it has a shutdown in the sequence. Now, because I'm not going to run a sequence right now, I want to make sure that I turn the detector and the pumps off before I walk away, because I will forget, and then we'll pump out all the solvents into the waste. Okay? So cool. Now you're armed and dangerous. So you can come and run your samples. So long as they're filtered, you can't break it from the keyboard. So don't be afraid. Run your samples.